Hello, it is that time for another daily coding problem. Today's problem comes from dailycodingproblem.com. It is a email newsletter. You sign up every day, you get an email. In that email is a question that was asked in an interview at some tech company, and usually the email tells you the company that it came from. Today's question comes from Facebook. Let's take a gander. As usual, I'm going to give myself an hour to work on this problem, so I'll start my stopwatch now, and we'll read through this. Hopefully, it takes less than an hour, because, yes, hopefully it takes less. Okay, so this problem was asked by Facebook. Let's read it together. Given the mapping of A equals 1, B equals 2, ... Z equals 26, and an encoded message, count the number of ways it can be decoded. For example, the message 111 would give 3, since it could be decoded in 3 different ways. And then they list out all 3 different ways. And you can assume the messages are decodable, so we don't have to handle any kind of weird input, like a 0, it looks like. So we will only have numbers from 1 to 26, and 2-digit numbers like 11 in this case here could be read as either 2 ones or as one number, an 11. Okay, this makes sense. So per usual, let's create some tests first before we actually have to think about how to solve this. And yeah, we'll go from there. So let's get started here. We'll create our solution test.rb and require some mini test because we get that for free in Ruby. And then we're also going to want to use mini test pride so we can get colors in our test output. And then of course we also want to require the file that we're testing, which is solution. And that should be require relative, right? It's going to be in the same directory. And now let's describe our solution. And what do we want to call this method? We are counting what are we counting? What does the README call it? Count the number of ways it can be decoded. Okay. Number of count decoded. There. Pretty straightforward, right? Count decoded. Seems good to me. It returns the number of possible decoded, returns the number of possible decoded messages. Okay, and then let's write our test. They gave us an example that has 3 possible messages. And that was for 111. While we're in here, let's add just like a few more. Might as well. So let's add one that just returns 2. That would be like 11, right? Because we have one message, which everything is a 1, and then we have a second version of the message, which is 11, which is K. And let's add one for a 1 as well. And let me just change the numbers here, might as well. So they're not always the same, right? Let's make this 23. And then for one result, we can do 9. And another one that will have one result will be, let's make it longer, but we'll have no double digits greater than, or no double digits less than or equal to 26. So something like 9, 3, 4, to 7. So there's no sets of 2 in here, I think, right? Yeah, there's no sets of 2 in here that are equal to, or that are 26 or less. So we only have one possible message that can come from this. And that seems good for now. We'll probably add another test case in here later. Well, that's enough to get us going, right? So let me run this. Of course, it's going to fail. And our first failure is we don't even have our file that we're testing. So let's create it. And while we're in here, I'm going to define our class and then define our method that we want to test as well. It was count decoded and it took a message. Very good. Let's run it again. We expected 3. Actual was nil. I'm going to bring our test back open. I'm going to bring it open on the other side. There we go. So great. Now we actually got to write code, right? Holy smokes. Let's see. How do we want to do this? Well, this kind of reminds me of like a permutation problem, right? That's basically what it is. So I want to use recursion. And I think what I want to do is, remember with recursion, we don't really have to know how it works. We just have to come up with a base case and then everything just works. So let's come up with a base case and see if it works. So the first thing we got to do before we can even start doing our recursion is we got to break this message up, because right now it's a string, right? And we want to break it up into an array of characters. So we have message.chars, and then we want to pass that to our method that is going to be recursive. So this can be, we'll just call it count. And that gets a set of chars. Now our base case here, what we're going to do is when our list of characters is empty, then we know at that point we've reached the end of a message, of one of the versions of a decoded message, right? So when chars is empty, we can return 1. So once we've got to the very end of looking at this permutation, we'll return the number 1 and add that to all the other permutations. And now we do our recursion. So we're going to want to return the count. So let's copy over our example here. We have 1, 1, 1, right? So what we want to return is, we have 2 possible things we can do here. We can take the first character. Man, I can't select one character. We can take the first character of 1 and then add it to the count of everything else in our message. Or we can take the count of 11 and add it to everything else in our message. And that's all we can do at this point, right? So we can do chars. We want the count of everything else but the first character. So the last... So if we have 3 characters, we want the count of the last 2 characters, everything that's in the last 2 characters. And we want to add to that the count of everything that's after the second 2 characters. And we've got a special case here. We only want to count 2 characters if that number is less than or equal to 26, right? Because like in this example, we want to take the count of 9 plus everything else that remains. But we don't want to take the count of 93 plus everything else that remains because 93 isn't a character. We only have characters of 26. So that means we need an if statement in here. We can grab, let's do this. This is going to be, call this next, we'll call this first two. First two is going to be chars.first2. And then we want to join these together. These are going to be two strings. We join them together and then we convert that to an integer. If that number, okay, let's save that to a variable because we're going to need to use it. If first two is greater than or equal to 10, and first two is less than or equal to 26, so if it's a character, then we're going to add this. Then we're going to add the count of everything except the first two characters. If this isn't the case, if we have a number that's not in this range, then we're going to add 0. It doesn't matter. Right? If this, return the count of everything except the first two, otherwise we'll return 0. I think that makes sense. And we're adding that to every permutation except for the first one, including the first character. So let's see what happens when I run this. Okay. It works. That's a relief. Cool. Well, let's see if we can add a test that breaks this then. Because this makes sense to me, but at the same time, it's kind of rare that something runs on the first time, right? Let's try it again. Okay. This is totally working. Man, recursion just like is such a mind thing. Man, okay. So let's do something that's greater than 3. I'm just going to type in a number here. 1, 2, 3, 4. I don't actually know how many combinations I should get, but let's see what my test says I should get. 3? Okay, let's do this. 1, 2, 2, 4. I want a bigger number. 5. Great. I'll take that. Okay, let's see if 5 makes sense for this number. So I'm going to copy this and try to do them by hand to make sure 5 seems like a reasonable number for number of decoded messages. So 2, 3, 4, 5. Let's try to make 5 different versions. So here's one version. We have 4 single-digit numbers. Another version would be if we consider 12 and then 2 one-digit numbers. Another would be if we keep 12 and we consider the last 2 as one letter. And then another one would be if we consider this middle one a number, right? And then our last one is just 24. Cool. This makes total sense to me. Let me write this in a different way so it's easier to read. So we have everything as a single number. We have the first 2 grouped together. We have the middle 2 grouped together. And we have the last 2 grouped together. And then we have two 2-digit numbers. So I think we're good. I'm going to add one more here. And this is going to be a case where this middle number is out of range. So maybe 20, maybe change that to a 4. So I would expect this to be the same, right? Except this middle one can't be counted on its own as a letter because it's 42. It's greater than 26. So I think that should give us 4. Let's try running it. Cool. Let's clean this up a little bit. I think that's all we need. How else would we clean up our code here? Yeah, I'm okay with this. This looks fine to me. The spacing on this is a little weird. Yeah, but it's readable. I kind of like having the indent there. Makes it a little nicer. Okay. Excellent. Well, it's been 15 minutes. Let's go ahead and toss this in a commit and push it up on GitHub. So that looks good. Let's check out our test. Our test looks good. Add solution to today's problem, which is 0208. And push it up. Close it out. Good. Clear our screen. Excellent. And back to the big version of me. All right. Cool. Well, that was great. That was from Facebook. They're probably not still using that problem today, so I'm sure if you apply for Facebook, you'll have something else to work on during the interview. I hope to do another one of these tomorrow, and thanks for joining me. See you then. Bye.